Hello and welcome to lecture number 13 in the course Advanced Robotics Applications. So today we'll start off with the lab experiments. In the last class I talked about the microcontroller which we are going to use from this class onwards. So in the last class I talked about the basic configuration of the microcontroller, the various pins, the kind of processor and the speed of the processor that is there on the Arduino microcontroller. So today we'll start off with our first experiment. Now in today's experiment, how we'll proceed in the experiment is that I'll explain what the experiment is about. So we have a lab manual which I'll very briefly explain. What are the various experiments that we are going to do. Then each experiment has an associated program. So you'll also be given the program and I'll explain the program. So we have a manual and there are programs for all of the experiments. And then when we'll physically do the experiment, that is you're going to connect the wires onto the various pins of the microcontroller and then maybe take a sensor input or take some output or control a motor, we'll show actually in the experiment. So today we'll start off by explaining what the manual looks like and what is the first experiment. So in today's experiment, it's very simple. First is to look at the various pins of the microcontroller to understand which pin is where, what do the pin numbers mean. And then do very simple connections and see how does a microcontroller actually give an output in a particular channel or take an input in a particular channel. Okay, so let's start off today by looking at the manual for the first experiment. So in the manual for this first experiment, and in every experiment we'll have a manual which will tell what we are going to do in the experiment. I'll first explain that, and then after that we'll move on to the actual physical experiment. So today is experiment number 1, which is basics of microcontroller. So our aim in the first experiment is to learn about the layout and the basic input-output capabilities of the Arduino Uno microcontroller. In the last class we had talked about the Arduino Uno microcontroller, which we are going to use in our experiments. Now the first task that we are going to do, so the tasks every day when we are going to do the task, they'll be written down like this. So this is the task that we are going to do. Okay, so the first task, that is task number 1, is to get to know the various pins of the microcontroller. So the various pins have numbers, as I explained in the last class. So there are the pins are designated by ground. They can have 5 volts, 3.3 volts, V in. Okay, numbers 8, 0 to A5, then IORF, reset. So these are numbers, okay, or names of the pins. So first is look at the microcontroller board and try and identify where each of these pins are. Okay. Then the next one, that is number 2, is we are given a program. So you'll be given the manual and a program, and I'll explain the program before each of the experiments. And you open the program in the Arduino environment, and then take pin number 8. Take the wire, connect it to pin number 8. Okay, and when you connect to pin number 8, one end to pin number 8, you take the other end of the wire and connect to each of these other terminals or other pins. For example, one end of the pin is connected to pin number 8, the other is connected to ground. Okay, and then it is connected to reset, then it's connected to IORF. And in each case, you see what is the reading on the serial monitor. Okay, so when you're connecting your microcontroller to the laptop, okay, the program will also display backwards and show you, the GUI will actually show you that what is being displayed from the microcontroller you can display on the serial monitor. So the serial monitor here is your laptop. Okay, or the GUI, the microcontroller GUI running on your laptop. So that is what we call by the serial monitor. So one end is connected to pin number 8, the other pin is connected to ground. Then what is displayed on your laptop? Okay, it will probably show you 0 volts because ground is 0 volts. Okay, so that is digital read. Next is you load task number 3. Okay, so we load task number 3, that is task number 3, and the task number 3 is basically to turn on the LED only if pin number 8 is low. Okay, so one end of the wire is connected to pin number 8, and the other end, when you connect it to ground, that means that pin becomes low. Only then the LED is turned on. Okay, it is otherwise it is turned off. Okay, so that is your experiment number 2. Then there are other experiments here. So the other experiments here are digital read. So when the LED is glowing, can you put a delay of 5 seconds delay in the loop of the last task, that is the glowing of the LED. Okay, so here what we can do is when you maintain the pin 8 at high. Okay, so what we are doing is in the last, what was the last task? The last task was here. So you are provided the program, and when pin number 8 is low, only then the LED turns on. Okay, now So the idea is here, introduce a 5-second delay in the loop of the last task. That means when you put the end of the one end of the wire which is connected to pin number 8 to ground, there should be a 5-second delay after which the LED will get activated. Okay, so that is the fourth experiment. Fifth is the experiment on switch on. That is this is a digital write. So write a code to alternately switch pin number 13 LED to high and low with a delay of 1 second in between them. So in the last class, I had shown you the program in which you can put on the LED pin to high or low and with a delay in between. So it's something like a Diwali light which blinks. So this is a blinking experiment of light with a delay of 1 second in between. Okay, so that is my digital write. Now about digital, digital write. Now about an analog write. Analog write is basically when you are writing a signal out on pin number 9. Okay, so we are write a code to apply a PWM signal on pin number 9. I'll just explain what is a PWM signal. So here, read the voltage at pin number 9 using a multimeter to actually see how much voltage is going out there. Okay. Now it's interesting to note that this is a digital device. So how can you have an analog pin, or how can you output an analog voltage? That means a continuous voltage. Okay. So the continuous voltage is in the range 0 to 255. So if you enter a number 0 to 255, it will correspond to a particular voltage, average voltage on the other side. And that is basically what is called a PWM, or a pulse width modulation. I'll just explain what that is today. Then there is an analog read. Okay, so this is my analog read. And then we move on to the various definitions that are there on the of the pins. So in the manual, what you can see is what each of the pins does is also written, and the details are given here. So for example, in task number 1, you're supposed to read each of the pins. Okay, not read, but to see where those pins are. So 5-volt pin, you can locate where is the 5-volt pin. Now what does this pin do on the board is written here. Okay, so this pin of the Arduino board is used as a regulated power supply voltage, and it is used to give supply to the board as well as onboard components and other external low current devices. So if you want 5-volt out from there, you can connect one end of the wire to that 5-volt pin. So what will come on that wire is a 5-volt now. So that 5-volt can be used for some purpose, like maybe making a LED glow, for example, okay, or for passing it on to a particular sensor. So this basically gives us, this gives us the various details of the pins. So we have a 5-volt, 3.3 volt. Then we have a ground pin, which corresponds to 0 volts. Okay. Then we have a reset pin, analog pin, digital pin, serial pin. Now, what do these pins mean? What do they do? Is the theory of that is given here. Okay. Then PWM pins, LED pins. Now we'll be using this PWM pins extensively when we control servo motors also. When we talk about servo motors, we are going to use our PWM pins. Now the Arduino board has a built-in LED that is on pin number 13. In the last example, if you remember, in the last class example, when the LED was blinking, we can either say pin number 13 or we have a built-in LED. It automatically understands that it is pin number 13. Okay, then we have an A reference pin and IO reference pin. Now, and there are also external interrupt pins. These pins in the Arduino board can be used to produce external interrupts. Okay, we'll have experiments with interrupts also. Okay. Then SPI pins. So these are the various pins and what they mean. Okay. Now we have talked about, I will physically show it during the experiment that these are the various pins and these are the numbers of the pins on the board. Now when we are connecting the Arduino, you use this particular kind of cable to connect one end of the cable to the laptop. So this is your USB connector. So the USB connector will go onto the laptop. And the other end of it will go onto the Arduino board. So this is also a USB connector which will go onto the Arduino board. That's how you connect the Arduino board with your laptop. And then set up the Arduino environment. Okay, that is my GUI by looking at which board I had explained in the last class. So when you're connecting the board to the laptop, you can look at tools. So click on tools, then click on Arduino Uno board, and it will show you which board is it that you're trying to connect. So you'll have to click that it's an Arduino Uno board that you're connecting to your laptop. Okay, then you have to choose the COM port. So in this particular laptop, we look at tools, and it is showing that Arduino is connected to Uno. The Arduino Uno board is connected to COM5. In different laptops, it can have different COM ports and can be connected to different COM ports. So this will show you that it is connected to COM port 5. So now you know how to communicate. The laptop will communicate with the Arduino board through COM number 5, COM port 5. Okay. So this is the setup. Now after the setup, we proceed. So in the first is, we talked about pin number 8. So where is pin number 8? So the first experiment was take a wire, connect one end of the wire to pin number 8. So take the wire, connect to pin number 8, and the other end of the, so this is one end of the wire, the other end of the wire is connected to ground. Okay. Now when you're connecting the other end to ground, what is the output that you're seeing on your serial monitor or on your laptop? Okay. So on your laptop, what is it that you're seeing? Are you seeing 0 volts? Okay. So this is the meaning of the serial output that is going to the laptop now in your C. So this means that when you're connecting pin number 8 to ground, this pin number 8 is becoming 0 volts, and that is being displayed on your laptop now. Okay. So in each of the experiments, when you're connecting different pins, for example, when you're connecting to reset, what happens? When you're connecting to 3.3 volts, what is displaying on your laptop? Okay. So this is basically to understand how can you generate different voltages, and how can you get different voltages, how can you utilize these different voltages to do different things on the board. Okay. Now digital read pin. So this is the digital read pin. So I'm going to connect digital pin, the digital pin to pin number 8. Okay. So what we are doing here is I'm connecting the digital pin here. So here, let's look at this one, digital read. So upload the corresponding task for task 3. Inside the code, the command pin mode 8 input pull up maintains pin as high when it is left unconnected. Observe the LED by connecting the disconnecting pin 8 to the ground. So this means this is an input pull up, and this means this maintains the pin 8 to high, okay, when it is left unconnected. So if one end of it is open, that means it is not connected, then it will be left to high. The moment I connect it to ground, it becomes low. Okay, so that is how you can make this pin high or low, basically, for maintaining an LED for different applications. Then we have a digital read. Then we have digital write. So in digital write, so first is upload the corresponding Arduino code and connect the multimeter to pin 8 as shown in the circuit. Then the multimeter knob can be set to 0 to 20 volt range. That means on pin number 8 on the multimeter, we'll report the change in voltage with time. We want to generate different voltages now. So it is connected this way. This is your multimeter. One of it is connected to pin 13, the other is ground. Okay. Now as we are running the program, you can see the voltage being generated on the multimeter now. Now analog write, PWM. Now we know that this is a digital device. A microcontroller is essentially a digital device, right? That is something I've been saying quite a few times. Now suppose you want to write different voltages, or you want different voltages. Okay, so from 0 to 5 volts you want different voltages. So 0 is completely 0 volt, that's ground, and 5 volt is the high. So this controller can produce 0 to 5 volts. Now suppose you want to produce say 2.5 volts. How would you do that? Now that is we can do this by using this procedure, what is called the pulse width modulation. So this is called pulse width modulation. Now in pulse width modulation, what we do, we have a square wave. This is my square waveform. Okay, at a particular frequency. Okay, so these are all square waveforms. Okay, these are all square waves. Now what we can do is, in a square waveform, we can keep this time. This is called the on time, and this is called the off time. So we can keep it on for some time, and we can keep it off for some time. Okay, so for example, 25% of this full width is kept as on. So it is called 25% duty cycle, analog write 64. So what it means is that 25% of the time, or 25% of this width, it is kept on, then it's kept off. That means, what can you imagine? So what it is doing is, this is one square wave, this is the next square wave. So only 25% of the time a square wave is being kept on. That means it is giving 5 volts for 25% of the time only. Okay, and then the rest of the time it is giving 0 volts. So what will be the output? The output is going to be an average voltage, okay, corresponding to this on time here. Okay, now if I keep, as it's very easy to understand, that if I keep it, for example, 50% duty cycle, I keep it for half the square waveform I keep it on, then I'm going to get half the average voltage will be half. Now if I keep it on for 75% of the time, then the voltage will be 75% of 5 volts. Okay, and how do I specify how much time I want to keep it on? By these numbers. So this is 0, this is 64. So this ranges from 0 to 255. So by changing the scale from 0 to 255, I can use PWM. I can connect one end of the wire to the PWM channel. And by specifying how much voltage I want on the output, I can specify a number 0 to 255. Okay, so for example, 64 means 25% on, 127 means 50% on, 191 means 75% on, and 255 is full duty cycle, which means it is full 5 volts. So this is 255. So your total volt output is going to become 5 volts. Okay. Now we can look at it. So what we are doing here is we are looking at, this is the PWM channel. Okay. So the tilde sign is there. So this sign. So PWM with this tilde sign. Okay. So you can see that. So wherever this tilde sign is there, those are PWM pins. This one, this one, this one. Okay. They are PWM pins. So I'm connecting one to the PWM pin, the other one is I'm connecting to ground, and then basically we are generating voltages, and in the output here I'll see how much voltage is coming. Okay, let's start off with our experiments. This is experiment number 1, task number 1. Now before every experiment I would read out the manual, which I have read out the manual and explained the various experiments that we are going to do today. So these experiments in experiment number 1 are divided into task 1, task 2, task 3, like that. In each of the tasks we are supposed to do a particular experiment with the microcontroller, and we are supposed to write down the results or explain what we are seeing as the result of the experiment on the microcontroller. And the first experiment that we have on the task number 1 for experiment number 1 is to get to know the pins of the microcontroller. So first is have a very good look at the microcontroller, because we are going to use this in all our future experiments. Okay, so this is the Arduino Uno microcontroller board, and as the name is written there, Arduino Uno. So Arduino boards have different versions, and this is the Uno version. And the microcontroller which is there, the microcontroller chip, is this one. Okay, so these are the various pins which are there, 1, 2, 3, 4. You can see the names, and these are also named as A0, A1, A2, A3, A4, like that. These are the power respective pins. There is the ground pin, 3.3 volt, 5 volt pins. Okay, now let's have a closer look at the pins. So if you look at the board, so this is the chip that is there. So if you see very carefully, it says Atmel. So it says an Atmel microcontroller. So here, if you see here, so that's the Atmel. It's written here Atmel and Atmel. So Atmel is the name of the company. So it is Atmega 328P microcontroller chip. That's the chip which is marked here. Okay, and these, if you see very closely now, these are called the power pins. So there's an IORF reset, 3.3 volt, 5 volt, ground, and V in. On this side, these are the analog pins. So A0, A1, A2, A3, A4, A5, like that. On the other side, we can see what are the digital pins. So these are the digital pins, which are numbered as 1, 2, 3, 4, 5, 6, 7, 8. Now in this digital pins, in the bracket you can see there, it's called PWM, or pulse width modulation, with a small tilde sign in there. I hope you can see the tilde sign. Okay, so whichever pin has the tilde sign, say for example number 3 and number 6 on this side, number 9, 10, 11, these pins can also be used as a PWM pin. Okay, so they can also be used as digital PWM, which means we can generate a PWM signal out from that. And this PWM signal can be used for controlling servo motors, for generating average voltages. Okay, now let's as per task number 1, let's read each of these pins and try to understand. So task number 1 says, what does task number 1 say? It says get to know these pins, the IORF, reset and ground. So there is a IORF. So this is my IORF pin. You can see that IORF. Okay, then there is a reset pin, then 3.3 volts, 5 volts, ground, and V in. Now suppose I want to take 3.3 volt as an output. What do? I connect a pin in there. What is the meaning of connecting a pin in there? Okay, so this is the wire. So this is the connection wires. You can see the connection wires here. So one end of it is pointed like this. There are 2 ends. The wire has 2 ends. And so what we can do is, suppose I want to connect this to 3.3 volts. So what I do is I take this one end of the pin find 3.3 volts. So this is my 3. This one is 3.3. So I insert it into the 3.3. Okay, so I insert it there. So this has gone into the 3.3 volts. You can see the pin like this has gone inside the 3.3 volt where it's marked. The other side is free. The other side of the wire is free. You can see that. Okay, it's still free. So the other side of the wire now is having 3.3 volt. Okay. Similarly, if I'm connecting to pin number 8, then what I do is I find pin number 8. Where is pin number 8? It's here. Okay, and this pin number 8 is here, and I take it here and connect it there. Okay, this is my pin number 8. Okay, so we have connected to pin number 8, and the other end now I can connect it to ground. So for example, if I connect this to ground now one end is connected to pin number 8. Okay, so this is how what we mean by connecting pin number 8 to ground, for example. Okay, now let me take off the pins, and what else are we supposed to look at? Now when you're connecting the microcontroller board to the laptop, then this is the connector that goes to the laptop. Okay, so this is the connector, and what we do is one end of it has the USB connection, the standard USB connection that goes into your laptop. The other end of it has this connection. Okay, this geometry of the connector. So this end of it gets connected onto this part of the microcontroller. So if you look at the geometry of this shape of this connector and the shape of this connector, then this gets attached onto this one. Okay, so this will get attached onto here now. So you can look at the shapes, they are the same. Okay. So now I can connect it here and insert it in there, and now it is connected to the laptop. So one end is here, the other end, the USB connector, which is this one, will go into the laptop now. Okay, now if you're interested in seeing what is the rear side of this, the rear side is like this. So you're not supposed to touch it with your fingers like that. Why? Because it will short. Okay, the terminals will get short. So we keep it inside a plastic casing so that you don't touch it that way and short some of the ICs inside. Okay. Okay, now looking more closely, what else can we see on this board? So on this board, the moment you put on the other end into the laptop, so it will start glowing. So there's a light here which says on. So it's a green color light which will start glowing, which means that you have connected the board successfully to your laptop now. Okay, where is it taking the power from? It is taking the power from the laptop. Now there is also an inbuilt LED, which is the small one here. That's an inbuilt LED. It is connected to channel number 13 internally. Okay, so if you say inbuilt LED, it knows it is channel 13, and so I can either say pin number 13 or I can say inbuilt LED. They mean the same thing. Okay, so these are the various digital pins along with the PWM pins. These are the various power pins. On the other side we have the various power pins which are here, and this is my analog pins. Okay, and this is the microcontroller. So this is the very basic of understanding what the Arduino board looks like, and this is our this is how you these are the various pins and how we connect the Arduino microcontroller board to the laptop. So task number 2, we'll look at the program. First we'll read and explain the program, and then we'll see what is the next program. The part number 2 program is to connect the pin number 8, okay, to various other pins, for example ground, reset, IORF, 3.3 volt, and look at the reading on the serial monitor. Okay, serial monitor is the laptop monitor where you can see what is the output that you're getting there. So we have just completed task number 1. So first I'll read out the task number 2, what we are doing for task number 2. So as shown in the manual here, task number 2 is digital read. Okay, so on the left side you can see it is written task number 2 and it's a digital read. So here the task is use the provided program for task 2 to digital read the pin 8 and print it on the serial monitor. Okay, so what we'll do is first I'll load task number 2, the program. I'll explain the program and then we'll perform the task. Now in this task it says connect the following pins to pin 8 and print the result on the serial monitor. Okay, serial monitor means this computer monitor itself, where you can see what is the output that is coming on pin number 8. So what we'll do is we'll connect one end of the wire to pin number 8, and the other end we are going to connect to, we'll keep it open, that's the first one. Then connect to ground, then connect to reset, then connect to IORF, then ARF, and 3.3 volt and 5 volt. And when we are connecting to these, we'll see exactly what is the value being shown on the serial monitor. Okay, so let's proceed step by step, and the first step that we do is to open task number 2. So this is task number 2. Okay, so this is my list of experiments. Okay, so this is the total list of experiments that we'll be having. So experiment number 1, this is task number 2. So I'll open the task number 2. So when I open the task number 2, it opens the file or the program, and you can see that the IDE 2.3.2 has been opened for the Arduino IDE. Now in this, I'll just very quickly explain the program. So the program here is says that these 2 lines that you can see, the 2 hash lines, these are comment lines. Okay, so line number 1, 2, 3 are comment lines, basically telling us what we are supposed to do. So line number 3 says connect the following pins to pin 8 one by one, none, ground, reset, IO-ref, A-ref. Then line number 5 says void setup, which is saying that pin mode. So line number 7 is pin mode 8 input. So it says that pin number 8 is an input pin. Okay, or it is being conferred, the pin number 8 is being configured as an input pin. Then a serial begin, and 9600 is the baud rate, okay, at which it is communicating, where the laptop is communicating with the Arduino processor. Now line number 11 to line number 16 is the program, what it is supposed to do. So the first part of the program tells the compiler what the program is supposed to do. Okay, so it sets up the pin mode and then the baud rate. The second part of the program, that is line numbers 11 to 16, tells what is the program, what is the task. So we can see here there is again one comment line which says put your main code here to run repeatedly. Now it says integer value is equal to the digital read, which is coming from pin number 8. Then serial print. So what it will print is the serial print digital read at pin number 8. So this is within inverted commas, so this will be displayed. Okay, now at the bottom side you can see here the serial monitor, which says at the bottom. Okay, so now it is saying not connected, select a board and a port to connect automatically. So we have still not connected the board, so it's saying not connected. So this is this, when we say serial monitor, this is what we mean, that this part is the serial monitor. Okay, so line number 14 says serial print, so it will print the line within the inverted commas which says digital read at pin 8. And then the next line 15 says serial print value. So this val is the value, so whatever value is coming on that pin 8 will be printed. Where it will be printed? At the bottom side here. Okay, and then after that pin number, line number 16 says delay 200. So there is a delay after it prints. Okay, so you can keep changing this delay for the print. Okay, so every time it will be taking, after 200 milliseconds it will be taking the value, printing it. Okay, so now let's start off by connecting the board. So we have connected the board to the laptop. The moment we have connected the board to the laptop, you can see that the green light on the Arduino, that the green light starts glowing. That means it has been connected. Okay, so it is showing the connection to the laptop. Okay, this is the digital monitor where it is showing after the output from the pin. Okay, at the moment we have not connected anything, so it is showing 0. Okay, so now please correlate line number 14. So line number 14 is saying digital read at pin number 8, and then it is saying serial print the value. So at the moment there is nothing, so it is showing digital read at pin 8 is equal to 0. Okay, so now let's connect the pin. So what are we going to connect? First we are going to connect one end of the pin. Now let me show you how we are connecting the pin. So we are connecting one pin to number 8. Okay, so you can see very closely that it is on pin 8. Okay, pin number 8. Now the other end of the pin is left free. Okay, the other end is free, it's not connected anywhere. So now what are we seeing on the digital monitor? Now on the digital monitor it is showing 0, sometimes 1, okay, because it can pick up noise from some place. Okay, so it is basically showing 0, 0, 0, 0, 0. Okay, so the end is left free. Okay, now let's connect it to, the first thing we'll do is connect to ground. So again we go there and find out where is ground. So ground is shown here. It is connected to the ground, we can see. It is connected to ground there. Okay, so once it's connected to ground, now let's come back and see what it is showing on my serial read. So on serial read it is showing 0. Okay, so that is then we take it out and connect to reset. Okay, so let's remove the pin and then connect to reset now. These are very small, so okay, now it is connected to reset. Okay, so now it has been connected to reset. Let me see it in this direction. Yeah, that is reset pin now. Okay, now what are we seeing on the serial monitor? It is showing 1. Okay, now let's connect it to IORef. So next we'll connect it to IORef and then see what it is showing on the. So it is connected to IORef now. That is IORef. Okay, that's the first one. And now let us look at, it is again showing 1. Okay, then next we connect it to 3.3 volts. So I take it off from, take out one end of the pin and connect it to 3.3 volts. Okay, so now it is connected to 3.3 volts. You can see that it's connected to 3.3 volts. Okay, now what is it showing here? Sorry, it is connected to AREF, not 3.3 volts will come next. So we connect to AREF and then we connect to 3.3 volts. Okay. It is connected to AREF, right? Yeah, it is connected to AREF. So when it's connected to AREF, what do we get there? Digital pin read is 0. Okay. Next, we're going to connect it to 3.3 volts. So the moment you connect to 3.3 volts, it is showing 1. Okay, so let's see that it is connected to 3.3 volts. Okay, and then we'll connect it to 5 volts. Okay, again we have connected to 5 volts. Okay, then we have connected to 5 volts now. Then we have connected to 5 volts. And what it is showing us here is the digital read pin is showing us 1. Okay, so this is task number 2. Okay, so after this we are going to open task number 3. So let me go back to the manual again. So this is task number 3 now. So in task number 3, it's a digital read. The previous one was also digital read. Now this one is a digital read. Now use the provided program for task 3 to turn on the built-in LED only if pin 8 is low. That means pin 8 is low when it is connected to the ground. That's what we have seen. Then when the moment you connect to the ground, what happens is it becomes low, it shows 0. Okay, and turn off otherwise. Okay, so it means that it will turn on the built-in LED only if pin 8 is low, and it will turn off otherwise. Okay, now in the code we have to upload the code for the task number 3. So let me upload the code for task number 3. So this is I open the program for task number 3, experiment 1, task number 3, and I upload this program. Okay, so this is the program for task number 3. Now let's look at the program first. So the program has the first, we are saying that LED pin is the LED built-in LED. Okay, this is usually pin number 13. So that's the first line. And we are saying next is input pin is 8. So we are defining the LED, which pin it is connected to, and we are also defining the input pin as pin 8. Okay. Then the part of the program, we are saying pin mode is LED pin is an output pin, and line number 10 is pin mode input pin is an input pull-up pin. Okay. So what is the meaning of this input pull-up? It means the input pin is set to high when it is left unconnected. Okay, the moment it is connected to the ground, it will become low. Okay. Now, what is the actual program doing? So from line number 13 to line 19 is the actual program. So it says the pin state is digital read. So it's the input pin. Okay, digital read is the input pin. Input pin is pin number 8. Okay, and if input pin is low, then you say digital write, that is LED pin is high. So if the input pin is low, then the digital write pin, which is the LED pin, that is made high. Okay, that means the LED will glow. Else the digital write, the LED pin is low. Okay, that is what the program is doing. Okay, so as I was explaining, it basically means that, as is explained here in the task line also on line number 3. So it is basically saying that it should glow only if the input pin is low. That means connected to the ground. Otherwise, it should not glow. Okay, so let's run it. Let's compile it. So this is, we are compiling, and we are after compiling, we are going to run it. Connect the pin to pin number 8. So one end is connected to pin number 8. Okay, it is connected to pin number 8 now. And the other end of it is connected to the ground pin. The moment I'm connecting it to the ground pin, that's the ground. Okay, what you can see is that the LED is glowing. Okay, so that is the LED which is glowing. So this is the LED that is glowing there now. So that is the LED. Okay, so maybe we can do it again. So remove the pin and put it in again. So we are removing pin number 8, it goes off. Okay, the moment you connect pin number 8, it starts glowing. That you can see. Okay, so that is what the program is doing. So that was my task number 3. Now let's move on to task number 4. What is task number 4 saying? Task number 4 is digital read. Now it says digital read and introduce a 5-second delay in the loop of the last task. That means in the previous task, we said that the LED should be turned on only when the other end is connected to ground, means it is low. Now here it is saying that it should be turned on after a delay of 5 seconds, delay in the loop of the last task. Okay, so as let me upload the program for the last for task number 4. So we are saying open. So experiment number 1, task number 4. So I upload the program for task number 4. Okay, so this is the program. Okay, so it is the same program that was there in the last task. Okay, so it says LED built-in pin, pin number 8. Then LED pin is an output pin. The line number 10 is saying that the LED pin is an output pin. And then pin mode, we are setting up the input pin as a input pull-up. Now from line number 14 to line number 20 is the same as the previous case. Okay, so it is basically checking the state of the input pin and is saying that if pin state is equal to low, then digital write as high, so the LED will glow. Else the LED pin will become low. Okay, so digital write LED pin will be low. Okay, in case it is not low. What I mean is the output and that pin is going to become 0 if the pin number 8 is not high. Sorry. Yeah. Okay, so now the difference here is that we have added a line which is 23, line number 23, which says there is a delay of 5000. Okay, so what it will do is after the LED pin becomes low, the pin number 8 becomes low, the LED will glow, but it will glow after a time interval of 5000 milliseconds here. Okay, so this is introducing a delay in the loop now. Okay, so let's run it and look at the program. So let's compile it first and then we can download the program. Now connect one end of the pin to pin number 8 and the other end of it we are going to connect to the lower ground pin. So it becomes low. Now you see that there is a delay. It has been connected but the LED is glowing after 5 seconds. Okay, so let's open it again and fix it in. So it is still glowing. Okay, now connect the pin again and let's see. So now once we connect the pin, what is happening? You see that it is glowing after some time. Okay, let's look at the manual again. Now in the manual, the 5th task is write a code to alternately switch pin 13, that is the LED, to high and low with a delay of 1 second in between. Okay, so in the previous task, what we were doing, we were putting a delay, we are making it high or low, the LED pin I mean, and then introducing a delay. So now here what we are saying is that we are going to make the pin high and low with a delay of 1 second in between. So we are going to blink the LED. Okay, so let's upload task number 5. So open task number 5. So experiment 1, task number 5. So this is the program for task number 5. So this is the program we can see. So here we can see that line number 5 is saying in the pin is pin number 13. Okay, so it is the LED pin. Then we are saying pin mode is the pin which is pin 13 and it's an output pin. Okay, so it is giving an output on that pin. So digital write pin high means we are making it high. Okay, and we are putting a delay of 1000. Okay, that means wait for 1 second. Then we are writing a digital write which is pin number 13. We are making it low. If you're making it low, the LED will not glow. Okay, and then we are putting a delay of 1000 again. And this loop is getting executed repeatedly. So basically what it is going to cause a delay of 1 second for the LED to glow and then go off again and then glow and go off again. So let's compile the program. So we have compiled the program and then we have run the program. Oh no, there's nothing to connect here. So automatically it will be glowing on and off. Okay, there's nothing to connect here. Okay, there is no need to connect. Okay, so you can see that the LED pin is going on and off. Okay. So if you want to see what's happening, you can see in the multimeter. Okay, it is making it high and making it low, making it high and making it low. Okay, that's the same thing you can see in the multimeter which is going on. Okay, and in terms of the LED, you can see the LED is glowing on and off with a delay of 1 second. Okay. Okay, so all this that we have done, that is number 2, 3, 4, 5, these are digital read and digital write. Okay, now in experiment number 1, but task number 6, we have an analog write now. This is a PWM, a pulse width modulation signal. Now what it says is write a code to apply a PWM signal on pin 9. So now we are using the PWM pin number 9. Okay, so in the last in the explanation of the basic pins of the microcontroller, I had explained that pin number 9, which has the tilde sign, is a PWM pin, and that's why this pin has been selected for this task. Now it says read the voltage at pin 9 using a multimeter. Okay, tweak the argument inside the analog write function in the range 0 to 255 and re-upload the code. Read the voltage again on the multimeter. Okay, so what we are doing is we are going to upload this value 0 to 255. 0 means 0, 255 means full range. Okay, so we can change this number and see what voltage is coming on the multimeter as an output. Okay, so let's upload task number 6. So it is task number 6. So open task number 6. Which is an analog write for PWM. So this is the program. Okay, so this is the program. Now it says that line number 5, line number 1, 2, 3 are comment lines. So just to read and understand. So it says connect pin 9 to multimeter positive and ground to multimeter negative. Try changing the PWM value and observe the multimeter volt reading. So line number 5 is saying PWM pin is 9. Okay, so this is telling the microcontroller that the pin number 9 is the PWM pin. Then from 7 to 8 it is saying pin mode. So PWM pin is an output pin. Okay, it is setting the pin mode. And then from line number 11 to line number 14 is the program what it's supposed to do. So it's saying PWM value 0, then analog write PWM value and delay 10 seconds. Okay, so we can change this PWM value here, and based on it we can see what is the output voltage that is coming, and there is a delay of 10 seconds in this loop. Okay, so let's compile this program and then run it. Okay, so we have compiled the program and we need to run it. So we also need to connect the multimeter so that we can see what is happening on the multimeter. So let me download the program. So this is upload the program onto. So please note this line number 12, it says PWM value is 0. Okay, so let me let us connect to pin number 9 now. Let us connect it to pin number 9 and the other is connected to ground. And then we are connecting the two ends of the wire to the multimeter. Okay, so this is showing as 0. Okay, so my PWM value was 0, so the multimeter is also showing as 0 now. Okay, now what we can do is, let me change the value here. So I'm changing the value of this to so let us change it to, what was the full 255. So if I change it to 255, it is changing everything to 255. Now I have to compile the program and download it again. Okay, so I'm compiling the program and downloading it again. Okay, so I've downloaded the program. Now you can see what value it is showing. It is showing 5 volts, 5.14 volts. Okay, it's a PWM signal, so it's showing an average voltage of 5 volts now. Okay, now I can change the value here again. Let me change the value to here I will change the value to half of that, say 125, 127. Let me change it. Okay, then what we do is we compile it and upload it. Okay, so now you see what value it will be showing. It is showing almost the half scale reading, 256 volts, 2.56 volts. Full range was about 5.14 volts. Okay, so this is basically showing that if you want to produce a PWM signal and the particular average voltage that you want to give, you can give it by changing this number in the program here now. So in this PWM value that we are putting, okay, that we can change. Okay, the next is to pin number 9 now. That is connected to pin number 9 and the other is connected to ground. And then we are connecting the two ends of the wire to the multimeter. Okay, so this is showing as 0. Okay, so my PWM value was 0, so the multimeter is also showing as 0 now. Okay, now what we can do is, let me change the value here. So I'm changing the value of this to so let us change it to, what was the full 255. So if I change it to 255, it is changing everything to 255. Now I have to compile the program and download it again. Okay, so I'm compiling the program and downloading it again. Okay, so I've downloaded the program. Now you can see what value it is showing. It is showing 5 volts, 5.14 volts. Okay, it's a PWM signal, so it's showing an average voltage of 5 volts now. Okay, now I can change the value here again. Let me change the value to here I will change the value to half of that, say 125, 127. Let me change it. Okay, then what we do is we compile it and upload it. Okay, so now you see what value it will be showing. It is showing almost the half scale reading, 256 volts, 2.56 volts. Full range was about 5.14 volts. Okay, so this is basically showing that if you want to produce a PWM signal and the particular average voltage that you want to give, you can give it by changing this number in the program here now. So in this PWM value that we are putting, okay, that we can change. So let's look at what is task number 7. So task number 7 is measure the voltage of the Arduino 5 volt pin using a multimeter. Let it be V1. Okay, so measure the voltage of the Arduino 5-volt pin. We have seen that there is 5 volt, 3.3 volt. So using a multimeter, measure that and let it be V1. Now use the provided code or the program to analog read pin A1. So we want to read pin A1. Connect pin A1 one by one to each of this and then check what it is reading. Okay, so first is one end will be connected to pin A1. Okay, and first of all, if it is connected to nothing, so if you are connecting pin A1 to nothing, then what is the reading? Okay, that means it is open. Next is it is connected to ground, then 3.3 volts, 5 volts, V in, A ref, IO ref pins. For each, map the analog read voltage between 0 to 1023, 20 to V1. Okay, now what it means is that we are connecting the V1, one end of the pin, to 5 volts. So one end of your scale is 5 volts. Now this 5 volt we are matching to 1023 and the other end is 0. So the 0 is being mapped to 0 now. Okay, so from 0 to 1023 we are mapping in the range 0 to 5 volts. V1 is 5 volts now. Okay, so this is what we are trying to do. So let us download the program for task number 7. So this is my experiment 1, task number 7. So I'm uploading task number 7. This is task number 7, and I also need to look at the digital monitor. So let's put it till there. Okay, so here again we see that we are defining line number 5. We're saying V1 is equal to 5000. Okay, and then analog pin is A1. So in this case, it's an analog pin, which is A1 now. And the analog pin, which is A1, is the input pin now. Okay, so what we are doing is in line number 14, we are seeing there's an analog value, which is the analog read value, which is the analog pin value, whatever is coming on that is being read. And voltage, we are mapping the voltage from analog value from 0 to 1023. Okay, and on the other side, this 1023 corresponds to 5 volts and 0 corresponds to 0. So we are trying to map the analog value range to the range of voltage from 0 to 5 volts. Okay, and then it will serial print the analog value. So the line within the inverted commas is going to serial print analog value, and it will show you the value also. That's line number 18. And then line number 19 says what is the voltage, actual voltage that is coming, and then it will print the actual voltage. That is line number 20. Okay, so let us run the program. Okay, compile the program, and then one end of the pin is connected to A1. So let us see here. You can see it, that is connected to A1. Okay, one end of the pin. Now the other end of the pin is not connected to anything. Okay, so the other end of the pin is free. Now what do you see on your digital monitor? So what it is showing is that it is not connected to anything now. Okay, so that is the first part. Next is we need to connect it to ground. So the other end of the pin is now being connected to ground. Okay, now I've connected to ground. So you can see that the pin is now connected to ground. Okay, so when it is connected to ground, what does the serial monitor show? It is showing 0 volts. Okay, that means what the pin A1 is reading is 0 volts now. Okay, the next what we do is we connect it to 3.3 volts. So we connect it to 3.3 volts. Yeah, so you can see that this part here, this one here is connected to 3.3 volts. Okay. The other end is connected to A1. Now what does it show? No, it's connected to 5, I think. It is showing 5. Okay, now see what it is showing. It is showing 3.3 volts. Okay. So now this 3.3 volts in the analog scale is corresponding to 656 or 655. You can see that. So analog value corresponding to 3.3 volts and it is not exactly 3.3 also, that you can see it's fluctuating a little bit. Okay, so it's showing us 3.21, 3.20. So we are mapping this now, the range from 0 to 5 volts to 0 to 1023, that analog range. Okay, so next let's connect it to 5 volts. So we are connecting it to 5 volt line now. Okay, so the pin has been connected to 5 volts. Okay, these are very, very fine pins, so it's difficult to see sometimes. Now if you look at the serial monitor, what it is showing you, it is showing that the full range value is 1023 and it is 5 volts. Okay, so this was the experiment, that how do you map that 0 to 5 volt range to the analog value of 0 to 1023. Okay, so that was the task here. Now we also need to map it to Vin. So next let's move it to Vin. Then we'll put it to ARF and IORF. Now it is put to Vin. Okay, so it has been put to Vin, you can see that. And what value is it giving you? It is giving you 4.5 volts. And what is the analog value? 921. Next we put it to ARF. Okay, now it has been put to ARF. Okay, what value is it giving you? It's giving you 1. It is fluctuating. So it's fluctuating from 1.25 to 1.7, and you can see the analog value is also changing. Now what about IORF? Let us connect it to IORF, that is next. So it has been connected to IORF. Now what value is it giving you? It is giving you 5 volts. Okay. Next task. So our next task is number 8, that is analog read. So using the provided code for task 8, connect the pin A1 to PWM and output pin 9. Connect one end of the pin to A1, connect pin A1 to PWM, output pin 9. Okay. Now that means we are connecting the pin A1 to PWM pin 9. Okay, so one end is at A1, the other end is at pin 9. Now analog value corresponding to 30% of duty cycle is already written in pin 9. Okay, so we'll upload the program for task number 8, which is a PWM program, and the duty cycle of the PWM program is already set to 30% duty cycle. Okay, so we will change the percentage from 30, 60, 85 to 100, and then see in the serial plotter what is the value in A1. Okay, so one end of the pin will be connected to A1, the other end is connected to pin 9, which is the PWM pin. So let's upload task number. So task number 8, which is analog read. Okay, so this is the program. Okay, so this is basically saying that this is my line number. If you look at the program carefully, line number 5 is PWM pin is 9, then line number 6 is analog pin is A1, and if you look at line number 8, it says duty cycle is 85%. Okay, and then PWM value is equal to, it is showing you the calculation. Okay, and this is the PWM loop which is going on. So it is setting the PWM pin as output pin, analog pin is the input, and it has PWM pin and PWM value there. Now this is the actual program from line number 28 to line number 38. So analog value is the analog read value that it is getting from the PWM, and then it is mapping onto the voltage which is being read. Okay, we had just calibrated 0 to 5 volts, right? So now let's compile the program and then run it. So we are connecting. You can see that one end of the pin is connected to the PWM pin, which is 9. Okay, and the other side of it is connected to A1. Okay, that is two ends of the wire. And what it is showing now is what it is plotting. So let's look at the plotter. So there is a plotter on top in that corner. That's the plotter. So it is showing you the PWM cycle which is going on. This is 85% PWM cycle. So 85% of the time the signal is on. Okay, that is what it is showing you here. Okay, now let me change. So this was 85% which was here. More on top, it was showing 85% here. Okay, so it was showing 85% right here. So what I will do is I'll change that. So let me make it 50%. That is 50% of the time it is on, 50% of the time it is off. So 50% now. Okay, so I made it 50%. Okay, now what we do is I will compile it again and then send it. Okay, now let's look at the plotter, what it is doing. Now you can see the square waveform. It is 50% time on and 50% time off. That you can see that, right? So the on time and the off time has reduced, and you can also look at the voltage that it is showing down there. Okay, now this is a PWM voltage which is going on. So it is, you can see that it is fluctuating. Okay, because it is exactly reading this. For some time it is on and sometime it is off. So it is going up and coming down again. So sometime it is 5 volt, half of the duty cycle. So half of that square waveform is 5 volt and half of it is 0 volt. Okay, and that's why if you look at the voltage at the bottom, it is fluctuating between 0 and 5 now. Okay. Okay, so that brings us to the end of our experiment number 1, where we looked at the basics of the microcontroller and how to operate, how to run the program, different kind of very simple programs of blinking an LED, how to read from the analog pin, how to use a digital signal like a PWM signal. So in the next exercise, we'll look at experiment number 2, where we'll interface with different sensors and then see how you can read different sensors by using the microcontroller. So today we'll stop here. Thank you.